The Raspberry Pi. If you've been on the internet in the last 10 years, you've seen these everywhere. They're used in everything from robotics, networking, media servers, pretty much everything you can think of. And these are the base for most budget hobbyists everywhere. Now, obviously, they're designed as low-cost, low-power machines. But with the most recent Raspberry Pi 4, they've gotten pretty powerful. So the question is, can we take one of these and make it into a decent home server? Well, let's find out. So to give this a fair shot, I'm going with pretty much the top of the line model. This is a Raspberry Pi 4 Model B with 8 gigabytes of RAM. This model is obviously running an ARM processor, and it is a 4-core processor running with a base frequency of 1.5 gigahertz. And the cool thing about these Raspberry Pi 4s is that you can actually run a 64-bit version of ARM on it. So that opens up a lot more flexibility in terms of the applications we can run on our home server. So obviously I'm not just going to put this on the desk and say, go. Come on. We're going to give it even more of a fighting chance by using one of the highest reviewed cases for the Raspberry Pi 4. This is the Argon 1 M.2 version. So what this does is allows you to incorporate an M.2 drive and connect that via USB 3. And then we can boot off of that M.2 drive, giving us much better performance than using the native micro SD card. Now the Argon 1 essentially comes in 3 pieces. You have the bottom piece, the top piece with an integrated fan, and the sister board. So the first thing you're going to want to do is take this sister board and line it up with your Raspberry Pi 4 with the 3.5 millimeter headphone jack and the 2 micro HDMI plugs, and it kind of just slots in. Major benefit of this case is that it converts these awful micro HDMI slots to 2 full-size HDMI slots. Now, once you have that done, you are going to want to install it on the top of the case. So it's easy enough. The first thing you're going to want to do is make sure that your GPIO pins align with the GPIO plug on the top of the case. And then once you do that, it kind of just slots in with a little pressure. So you can see all the ports are lined up. That means we are good to go, and we can screw this down. So one thing I didn't mention is that you probably saw the thermal pads that had already been applied. Those are supplied by the case, and you're going to want to install those on the CPU and the power delivery. That's going to make sure those are contacting the actual case, which is aluminum and is going to act as a giant heatsink and keep your power delivery and CPU fairly cool. So yeah, everything is nice and secure. I think you can actually use more screws, but I have 4, so it's in. The last piece is actually the bottom piece, and this is where you install your M.2 drive. Now you can see I've already installed mine. I'm using a Kingston 128 gigabyte M.2 SATA SSD. Make sure you are not going with an NVMe SSD because that will not work with this case. And since you're connecting it with USB 3.0 anyway, an NVMe drive would be completely wasted because you can't get nearly NVMe speeds with USB 3.0. It's fairly easy. It's connected via this little USB to USB adapter. It kind of just fits on and screws down. Again, we have 4 screws. Am I dumb? Oh, I made a mistake. This has happened to me once before. Before, when I said there's more than 4 screws, so this one is actually going to be held down by the other case screws that we are going to put in. So leave this one open. The screws you're going to want to use are here, 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 and here. So now you can see when we put the case on, it's going to be held down here, 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 and here. Lefty-loosey, righty-tighty. It's like my dad used to always say, if you think you're missing screws, then try putting the case together first and then go back. And if you're still missing screws, then you actually might be missing screws. Here's a clever guy. To connect the actual SSD to the Pi, like I said before, we're using this USB adapter. It kind of just plugs in right here. It connects that SSD board to the actual Pi, and then that's it. We have everything hooked up. Now, one cool thing about this case is that you still retain access to the GPIO, so it's kind of covered by this magnetic cover, and you can put it on to cover it up when it's not in use. Okay, networking. One good thing about the Pi 4 is that you do get gigabit networking, which comes in handy when you are running home server type services. There's your power, USB-C, mouse and keyboard, and full size HDMI. Power on. Okay, so for the operating system, I went with Ubuntu 21.04. You can go with any version of Ubuntu desktop. You don't even have to go with Ubuntu desktop if you don't want to. The reason I chose this is because it's a solid, reliable 64-bit ARM Linux operating system. You can go with the server version, but I went with the desktop version specifically because if you want to use this Pi, as a Pi and have access to the GPIO pins and kind of mess around with desktop software, you still have that option as well as running home server type services. So here we are in Ubuntu desktop. Now, off screen, I went through the whole dealing with how to boot directly off of the SSD. I used a very awesome guide. I will link it down below. If you follow that to a T, you will have the same experience I did. It was extremely easy, extremely straightforward to get your Raspberry Pi booting from the SSD instead of the micro SD card. So here we are. This is Ubuntu Desktop 21.04. This is running everything right now as we speak. So if you're looking at this for the first time, the first thing you're going to want to do is install Docker. Now, Docker is going to be what allows us to easily run all the services that we want to use in our home server setup. Now, on top of Docker, we will be using Portainer as our Docker orchestrator. Now, once you have Docker installed, you can install Portainer. It's super easy, a couple of commands, and Portainer is installed. Now, by default, Portainer is exposed on port 9000. So once it's up and installed, you can go into Portainer. So you can see mine's obviously running on port 9000. And when I go into my containers, you'll see I have all of the things here that we want to run. Now, if you look at this list, you can see that we're running things like Wordpress, FileBrowser, Plex, Heimdall, PiHole, and the list can go on, but that is just what I have running on my little Raspberry Pi here right now. Now, when you first install Portainer, the only things you're going to see in your containers are the actual Portainer containers running. You probably won't have anything else. So the first thing I actually went and installed was WordPress. If you haven't heard of WordPress, I don't know how you're even on the internet right now. WordPress is essentially a streamlined website hosting service that can be hosted on pretty much almost any hardware. It's extremely flexible. So you're probably thinking first step, go into app templates in Portainer, and oh look, if we scroll down, look at that. We have a WordPress just template ready to go. Now, this isn't going to work on the Raspberry Pi 4. By default, it doesn't use a version of MySQL that is compatible with ARM64. So what we're going to have to do is make our own little custom template of WordPress. And you might find that you have to do this for a couple of these templates that don't necessarily work by default on the Raspberry Pi. So it's pretty easy. Go into custom templates, and you can see I have 3 of these here, but we're going to look at the WordPress ARM one. And to create a template, it's as easy as just pasting your Docker Compose YAML file directly into the specified location. So if we go to edit, you can see here's our Docker Compose. You will notice right away that we are using version 2. This is not optimal. I think we're up to Docker Compose version 3.8 at this point. But as of right now, the version of Portainer for ARM64 does not support any new versions of Docker Compose. It only supports Compose 2.0. So we can still get things running using 2.0, but just let that be a note. Here you'll see we are running a WordPress service and a database service. Now we are using a MariaDB, which is essentially a fork off of MySQL. So we are using that, which actually has an image that is supported by ARM64. And you can see, you know, this is standard WordPress stuff, basic environment variables. If you want to hack into me, here you go. My username is WordPress user and my password is password. Come hack me, bro. But yeah, you would obviously replace these with the passwords and usernames that you'd want to use, but it's as simple as that. Paste it in here, save the template, and then you can just click on any template that you can create and deploy the stack. Now this is going to create your stack. And if you go back into containers, you should see everything running. I've already done that, and I have a WordPress. Now I can't talk. Woo. Now I do have a WordPress site running on the Pi. It is not an impressive site. It is a basic template just to show you that it works. We can host a WordPress site. It's running on port 8080. And yeah, you can see, obviously this is running on the Pi, same IP. So yeah, we now have a WordPress site that we can host. If you want to expose that to the outside internet, you can certainly do that. I have a video showing you exactly how to do that safely using pfSense. Click up here if you want to check that out. So yeah, moving on. You're hosting a website directly on your little Raspberry Pi. Now, maybe you want to host a file browser. So let's install something where you can browse files through the web page. Now, luckily, in app templates, if we go back in there, you can scroll down. You can see there's already a template for FileBrowser. And luckily, this one works natively on the Raspberry Pi. So you can just click on it and deploy the container, and it will work just like that in one click. Now, if we go to my version, you can see it's by default hosted on, it picked a random port. So to figure out what port it's actually hosted on, it's really easy. Go into your containers. You can see FileBrowser is hosted on 49153. We have FileBrowser. Now what FileBrowser is I would say a streamlined version of Nextcloud. This allows you to host a file system that is accessible and editable directly in your web browser. So, you know, obviously you can create new folders, you can create new files. I have a folder here with some top secret information in there. Oh, okay. What's that say? Okay, so yeah, FileBrowser. Again, if you want to expose that to the internet, follow that same guide I linked before. It's really cool what you can do with this. I mean, accessing a file system directly in the web browser is extremely powerful and convenient, very basic and easy to use. You can download this file if you want. You can actually share files as well. And you can specify how many hours, minutes, seconds, days you want this to stay active for. You can set a password. And when you share, it can give you a link. So for example, if we want this for 2 hours, the password is taco salad. And when you click share, it gives you a link. And you can copy this to clipboard, send it to whoever you want. If they can access your Pi, then they can access this file. So if you have this exposed to the internet, then boom, easy file sharing to anybody in the world with this extremely lightweight service. Okay, so we have a website, we have a file system. What else do we need? Let's see, PiHole. Everybody runs PiHole on their Raspberry Pis. Our Pi home server is going to be no different. PiHole, how do we get that? So there's no template for it, obviously. So custom templates, we made our own, and it's extremely basic. Let's take a look at it. Yep, pretty basic. Again, version 2, set some basic environment variables, the ports that you want to use, and deploy it. We're on port 7080. So if we go in here, you can see PiHole is running. Now, obviously I'm not logged in. All right, so we're logged in. Now, obviously I'm not running this right now because I didn't want my network to act freaky when I'm turning this off and on, back on for this video. So this isn't really a tutorial about how to use PiHole. There's a billion of those on the internet. So if you want to figure out how to use PiHole, check out literally any other guide. But yeah, PiHole, if you don't know, it's a really cool little piece of software. What it's going to do is act as essentially your DNS server for your local network, allowing you to filter all types of things, you know, specific websites, even ads. A lot of people use it as an ad blocker. It gives you information on what your network activity is doing. And it's a pretty cool piece of software. I definitely recommend it if you have a little Raspberry Pi home server. Now you can run this, it doesn't have to be on a Raspberry Pi. Most people just run it on a Pi because it's lightweight and extremely efficient, but now we have that running. Moving on, can you use Plex? No way you can run Plex on this little thing, but we can. Again, app templates, custom, and let's take a look at our Plex custom template. Wow, super straightforward. Now we're using a specific Docker image for Plex that is compatible with, again, ARM64 and our Raspberry Pi. But again, you can see there's not much to it. Very little environment variables. The one important one on here is your volumes. This is going to be where you want to pass in some local folders. If you have a bunch of stuff stored locally on the Pi, you can pass that into the container and use that as your Plex storage. Super straightforward. Deploy it and run it, and you can see here is our Plex dashboard for our Pi. It is running, and to show you that it actually works, let's play some really quality content. Okay, yeah, Plex works. Now I also have a 4K version of Die Hard on there that I ran, and everything ran pretty smoothly. Now, if you're going to be running like encoding stuff for multiple users and doing any type of fancy encoding for different devices, yeah, this Pi isn't really going to handle that. But for basic Plex use, it works, which is kind of impressive. And last but not least, on our home server, we are running Heimdall. And Heimdall is something that I use in basically every home server that I build. I recommend it to everybody. It's a super cool piece of software. It's essentially a lightweight dashboard for all the services you want to have linked within your ecosystem. So here you can see all the things we just talked about: FileBrowser, Plex, Portainer, Wordpress, PiHole. You don't want to remember all the IPs and ports of all these different services you have running. So what you can do is create a dashboard that kind of organizes them and essentially are links to that. Now you can say, oh, well, I can just create favorites in my web browser and that's what I use. Okay, but what if you get on another computer? And what if you use a different browser? And what if you're outside of your network and you don't have access to your favorites, but you want to VPN in and have access to all these things? Every single time you visit this, they will all be saved and in the same location for any device. So yeah, it's basic, but it's useful. So that's why I include it. Now it's really easy. When you come in here, it's going to be blank, but it's super easy to add things. You can go into this little list icon over here. And when that comes up, you're going to have a list of all your kind of services or links. You can add one pretty easily. Give it a name. They give you a huge list of very common services that people run. And all of mine were actually in here. So you can, as I'm scrolling through, you can see a whole bunch of stuff. When you pick it, it's going to give you a custom color theme as well as the icon. But if you don't see yours, that's fine. You can upload any custom icon you want and change the color as well. So, but yeah. And for Heimdall, installing it was extremely easy. I didn't have to use a custom template. I actually just installed it a straightforward way, going into containers, adding a container. And then for the image, I just used the basic Heimdall latest image from Linux server Docker repository. So yeah, this is the one you're going to want to use if you want to install Heimdall on your Raspberry Pi. That is it. Now, one major thing that makes this awesome is its power use. So everything is up and running now, and we're legit hovering between 4 and 5.3 watts. That is extremely power efficient compared to even the tiny home server I built in my last video, which was supposed to be power efficient. I think was using 40 something to 50 watts. So almost 10 times what this is using. Now, obviously it's more powerful. I'm not getting up here and saying that, you know, this Raspberry Pi is going to replace your home server. That's obviously not true and was not the point of the video. The point of the video was, can we have a usable home server on a Raspberry Pi? And I think the answer is yes. But that's it. I hope you enjoyed it. I hope you found this somewhat informative. I do want to know if any of you out there are running some fancy stuff on your Raspberry Pi at home. So let me know down in the comments what you're running on your Raspberry Pi. Now I have like 1,000 of these in the drawer over there. So give me some good ideas and maybe you'll see your idea in a future video. But that's it. Drop a like below. Please consider subscribing if you like this kind of content. I appreciate you watching, and I will see you in the next one.